No. Definitely, it can be. Definitely, it can be incorporated into the existing building, because existing building, you know the challenges what you need to address in renovation of the building and systems. So I would say definitely there are a lot of chances that you can get into regenerative architecture and renovation, architectural renovations and retrofit solutions to your system in existing building, and definitely it's a possibility. But it needs a proper understanding of the existing scenario and engineering and architectural upliftment. So all these things needs to be done, and it is not just the systems. See, there is a catch here. If you want to keep your architecture and facade same, and if you want to get into regenerative, you can do it. But the say regeneration or giving back renewable energy to the grid, you can still do it, but in that way you will not be optimizing or reducing the cost impact on doing that, because already your building is inefficient. Your heat lot of heat load coming into the building, daylight not utilized, and still you want to get into regenerative thing of renewable energy. It's a big no. First you need to handle the building facade, increase the daylight, reduce the heat gain, optimize your HVAC system, lighting system. So because what we have found from our experience is that if you see HVAC system, by building and building optimization and glazing optimization, shading, and selecting a efficient HVAC system, you are able to reduce 45 to 50% of your heat gain and operational HVAC energy. One thing which I could suggest, easy to use, which any architect can use, is developed by World Bank and International Finance Corporation. Many of us would have heard of EDGE tool, EDGE, EDGE tool. So if you type EDGE Green Building Certification in Google, it will take you to the web page where you can register yourself and use a free Excel-based tool, where it is as simple as giving your building plan, your north orientation facade area, south orientation facade area, U value of the glazing. All these things, if you input, it will show you where you stand, and you keep on improvising your building parameters on building envelope, building systems, and everything. It will, and also you can put the percentage of renewable energy system what you can install, and based on your economical constraint or the site constraint, and hot water system, heat recovery system, everything is integrated into the tool, where you don't really have to model the building physically, but you need to give certain building facade and building height and number of floors and building footprint parameters, and wall to window ratio, and shading parameters. So all these things can be input with very handy information what an architect has project. So if it is a residential thing, I would say in residential, if you are handling the building sustainability aspects, heat gain aspects in a appropriate way from the design stage, uh, I don't see air conditioning requirement, at least in climates like Bangalore, which is a moderate climate. Yes, in places like Delhi, which is a composite climate, you may require air conditioning to a certain extent. But there also in air conditioning industry, there are a lot of two-stage evaporative cooling systems which can really keep you at a moderate cooling level even in places like Delhi and Hyderabad, and people have started using it. So you can really look at electromechanical HVAC systems which are efficient, and there are systems which are not like cooling, but giving you that comfort with evaporative cooling or two-stage evaporative cooling. So residential, if you ask me, you can look at a two-stage evaporative cooler system. But if you really require air conditioning, you need to go for VRF systems with high COPs, means coefficient of performance above 4.1. So that would be, I would recommend for residential, because concepts like chilled radiant cooling, which is appropriate for offices, may not be able to you may not be able to operate it, install and operate it in residential projects. But yeah, residential, you can go for a efficient VRF system, variable refrigerant flow, what we call it as. But offices, definitely we can go for the economical option. When you say for efficient cooling, one first thing would be the UFAD, underfloor air distribution. You guys would have come across raised floor, and that we can raise it up to 350, 400 mm and go for a underfloor air distribution, where your underfloor raised floor helps in networking, electrical cabling, and easy flexibility for changing the workstation configuration in your project. But at the same time, pump in air from below. So the advantage of that is you have if you have when you have a top discharge and top return in a office building, you need to cool the supply air much more. Like the supply air temperature will be 13 degrees, 14 degrees. But when you have a bottom discharge and top return, it's a unidirectional flow of air, and you can just cool your supply air up to 17 degrees to 19 degrees. So you're saving on the chiller power consumption, and you're cooling the building more efficiently. But beyond that, if you want to get into much more efficient system, definitely radiant cooling is more appropriate. Today we are in a more efficient scenario, or the green building scenario, where at least we are confident of reducing 60% of water consumption in our buildings, and 50 to 40 to 50% of energy consumption in our buildings compared to conventional buildings. So next level is sustainable building, and what we are heading to is the net zero scenario of energy, water, and even waste. But yeah, net zero energy approach is something which I can say that, as I mentioned, that renewable energy utilization in your projects is not merely restricted to on-site renewable energy installations. The regenerative aspect also comes into flora, fauna, and ecology, what I was mentioning, where you develop that kind of leaf area index. So leaf area index is a very good index to analyze and use in your projects developed by University of Singapore, where you analyze for every square meter of your green scene in plan, how much area of leaf you have. So a good leaf area index is between 1:4 or 1:6, means one square meter in plan, what you see as a bird's eye view, may have 6 meter square of leaf area or 4 meter square of leaf area. So it also makes you think what kind of landscape you want to have, and that will automatically create a positive impact on reducing the heat load in your buildings and inviting more birds and other species, and it will also conserve water in your project. So all these things are regenerative. So now there is a clear line between what we just call as sustainable projects. So we have not reached that maximum level of sustainability also, because we are not, all of us are not net zero in all aspects of energy, water, and waste, and we have a long time to go. And regenerative is few projects, if you can rethink, or if you can think of giving it back, and also having having invited more flora fauna into your project, you can call it as regenerative. No, green rating, I would say it is, we have done the damage and we are trying to pull the strings and, trying to control the damage what has been done. So green rating, I can say it is just a tool. I think I mentioned previously also in this presentation that green rating or any certification is just to say that, okay, be sustainable to a certain extent. But definitely, if we, at least in the medium-sized projects or residential projects, if not huge IT parks, may still rely on renewable energy purchases and other things. But at least medium-scale commercial projects, office projects, and residential projects of medium scale, we can definitely try and achieve regenerative architecture in terms of planning and energy utilization and ecologic flora and fauna.
Great. This has been an amazing session. Deepak, thank you so much for discussing various aspects of sustainability. I thank everybody who has joined here. And also going forward, you will see this conversation on YouTube. I will request all of you to drop a line in terms of what you would want to hear next from Deepak and upgrade your understanding of sustainability-based designing. So thank you so much for your time and really appreciate it. Thanks, everybody.
Thank you, everyone. Thank you, Meghna. Thank you.